Get ready to dive into the captivating world of solar eclipses and an enigmatic phenomenon known as shadow bands. These mysterious bands have intrigued scientists and skygazers for centuries, and we're about to unravel their secrets. Imagine this: just before the moon completely blocks the sun, you witness a mesmerizing dance of light and dark. Long, dark lines, separated by white spaces, race across the ground, almost like phantom serpents. It's a spectacle that has captivated people for generations, and we're about to explore why. Now, let's talk about David Turnshek, a physicist and astronomer who first encountered this phenomenon as a teenager. He witnessed these shadow bands during a total eclipse near Virginia Beach in 1970, and it sparked a lifelong curiosity. Turnshek's primary research focuses on distant galaxies and quasars, but his fascination with shadow bands has endured. It's like a cosmic puzzle he can't resist solving. Here's the intriguing part: there are two competing theories about shadow bands, but no definitive explanation. One theory suggests that turbulence in the atmosphere, the irregular motion of air currents, creates these bands. It's similar to why stars twinkle when viewed from Earth. But with the sun, its massive size usually prevents us from seeing this effect. The other theory involves diffraction and interference, where light waves bend and interact when encountering an obstacle, like the moon's curved edge during an eclipse. In 2017, Turnshek and a team of students, the Pitt Shadow Bandits, set out to test these theories. They secured NASA funding and traveled to Tennessee to study the eclipse. They placed light detectors on the ground and on a high-altitude balloon to collect data. The results? Well, they were surprising. The team found a sustained signal of 4.5 Hz at both high altitude and on the ground, which challenged the prevailing theory. It suggested that both turbulence and diffraction interference might be at play, adding a layer of complexity to the mystery. Fast forward to 2024, and Turnshek's team attempted a similar experiment in Texas. Unfortunately, cloud cover prevented them from detecting shadow bands. They deployed high-altitude balloons and sensitive sensors, but to no avail. It's a reminder that nature doesn't always cooperate with our scientific endeavors. Now, here's where it gets even more fascinating. Turnshek and other researchers are gearing up for the upcoming total solar eclipse on Wednesday, which will sweep through parts of Russia, Greenland, Iceland, Spain, and Portugal. Turnshek will be in Lyon, Spain, primarily as a tourist, but he can't resist bringing along one of his electronic detectors. He hopes to capture video evidence of shadow bands using ground-based equipment. However, without measurements from above, the mystery remains unsolved. What makes this really interesting is the involvement of citizen scientists. Joe Conti, an independent researcher, is encouraging eclipse observers in Iceland and Spain to capture shadow bands on their smartphones. It's a brilliant way to engage the public in scientific discovery. Personally, I think this is a fantastic example of how science can be accessible to everyone, and how everyday people can contribute to solving cosmic puzzles. So, if you're lucky enough to be in the path of totality on Wednesday, keep an eye out for these elusive shadow bands. They're easy to miss, but if you're south of mountains and coast, and heading west for a higher sun position, you might just catch a glimpse. Remember, it's a fleeting moment, so be prepared and keep your eyes peeled. This natural phenomenon is a reminder of the wonders of the universe and how much we still have to explore and understand. It's a mystery that keeps scientists and enthusiasts alike captivated, and I can't wait to see what new insights we'll uncover in the future.